Hello, so this is the end the video answer key for this worksheet. I'm going to go through a couple of questions and you guys can use those as a model to how to do the rest of them. And of course I have the written full answer key that should be up on Canvas by the time this video goes up too. So check that out. Let's go ahead and do this first question. So I have here this amount of silver react with this amount of hydrogen sulfide. Which reactant is the limiting reactant and which is in excess? Now there's a couple ways we can go about doing this, but the easiest way is for you to do two different calculations to figure out how, if I were to use this much amount of silver, how much of the product would I get? And if I used up this much amount of hydrogen sulfide, how much product would I get? Now I'm just going to choose a random product to do these calculations with, and I'm choosing hydrogen gas here just because the molar mass of hydrogen gas is simple. So first of all, we need to figure out the molar masses of each of these reagents that we need to do the calculations with. So I know that the molar mass of silver is 107.81 gram per mole. And then I know the molar mass of hydrogen is just 2 times 1.008. That gives me 2.016 gram per mole. And then I need to know the molar mass of hydrogen sulfide too. So that is 2 times 1.008 plus the molar mass of sulfur, which is 32.07. You can get these numbers from the periodic table, giving me the final molar mass of 34.9 gram per mole. Right, so for these two calculations, what I want to do is I want to go from gram of reactant to mole of reactant to mole of product and to back to gram of product. So, and the product we have chosen is hydrogen gas, so H2. Now let's set these two calculations up. Let's start with our first reactant, which is silver. So I do 42.5 gram of silver. I'm going to use the molar mass to convert that to mole. So I know that silver, the molar mass is 107.81 gram. That's per 1 mole of silver. Then I want to convert that to the mole of the product using our balanced chemical equation up above. So I forgot to balance that, so let's do that real quick. Silver right there. Okay, that should be balanced. Now I know I have 2 mole of silver to 1 mole of H2. Now we want to convert that back to gram of H2 by using the molar mass. So and the molar mass for H2 is 2.016 gram. And then when you punch that into the calculator, you should get 0.3971 gram of hydrogen. So if I were to use up the entire 42.5 gram of silver, I would get 0.3971 gram of hydrogen. Now let's do the other calculation for our other reactant, which is hydrogen sulfide. So let's do 46.1 gram of hydrogen sulfide. I want to convert that to mole of hydrogen sulfide. Mole of hydrogen sulfide, and I know the molar mass is 1 mole of that is 34.09, which is what we found earlier. Now I want to use the mole ratio to go from mole of H2S to H2, and I know that the molar, and I know the mole ratio is a 1-to-1 ratio. So here we go. 1 mole of that is 1 mole of H2. Then what we're going to do is converting that back to gram. So I know 1 mole of H2 is 2.016 gram of H2. That's the answer. 0.73 gram of hydrogen sulfide. Now taking a look at which one is our smaller number, I can see that this is my smaller number, so the reactant that produces the smaller amount of product is my limiting reactant, and the reactant that produces the bigger amount of product is our excess reactant. So in this case, our limiting reactant, to answer it here, is silver, and our excess reactant is hydrogen sulfide. I'll do a little highlighting here to show you which one is our final answer. There we go. So your final answer is just that the limiting reactant is silver and the excess reactant is hydrogen sulfide. However, you do need to show these count calculations in order for your work to count on the worksheet and also on the exam. So just keep that in mind. So you can use what I just did in number 1 as a model for what you can do for number 2. Alright, so let's see what we have here. We have lithium nitride is made from this reaction between lithium metal and nitrogen gas. Let's go ahead and write out our reaction first. My reaction is 6 lithium, or this is my balanced chemical equation, gives me 2 lithium nitride. So that's my balanced chemical equation. Now the question is asking me to calculate the mass of lithium nitride that's produced if you were given this much of nitrogen and this much of lithium. So let's go ahead and do that. So now, as I said before, you have 2 pieces of information. You need 2 different calculations. And we're going to actually do something kind of similar to what we just did in number 1, and what you should have done also for number 2 is we're going to do 2 calculations going from one reactant to the product. So our your calculation should go from gram of reactant to mole of reactant, because remember, if your number is not in mole, you want it to be in mole. And then you want to go to mole of the product, and then lastly back to gram of the product. And in this case, our product is lithium nitride. So in order to do all this, you need to know the molar mass of all 3 of these reagents actually. So assuming that you know how to do that, just using the periodic table, let's go ahead and get started with our 2 calculations. So first of all, on my first calculation, I'll do lithium. So I have here 56.0 gram of lithium, and I want to convert that to mole of lithium using the molar mass. And I know that the molar mass of lithium is 6.44 gram per mole. And then I want to convert that to mole of the product, which is lithium nitride. So mole of lithium at the bottom, you want it to cancel out, and mole of lithium nitride at the top because you want to keep it. And looking at our balanced chemical equation, I know that the ratio is 6 to 2. Then you want to convert that to gram of lithium nitride. So you want to put mole of lithium nitride at the bottom and a gram of lithium nitride at the top. Of lithium nitride is 34.53 gram of lithium nitride. Now after you got this done, we can punch it into the calculator, giving me 13.9 gram of lithium nitride. Now this is not our final answer just yet, because we still need to do that second calculation, and then we need to compare the answers to see which one is our smaller number, and the smaller number is the final answer that we're looking for. So let's do our second calculation, which is 5.60 times 10 milligram of nitrogen. And since we know that milligram doesn't appear in our molar mass, we have to convert milligram to gram. And we can do that by, I know that 1 gram is 1,000 milligram, or 10 to the third, whichever one works is fine. So now we have converted to gram. We can do the same thing we always done, is that going from gram of reactant to mole of reactant. So gram of reactant at the bottom, and the molar mass for N2 is 28.02 with 1 mole of N2 at the top. Now going from that to mole of our product, which is lithium nitride, I want mole of N2 at the bottom, and I want mole of lithium nitride at the top. And that is 2 to 1 according to our balanced chemical equation. One last calculation, I'm just going to write it down here since I'm kind of running out of space. I know that I need to cancel out mole of lithium nitride. So that's 1 mole down there, and then I want gram of lithium nitride here because that's what I want at the end. And our molar mass is 34.53, giving me the final answer of 93.7 gram of lithium nitride. Now what you have here is 2 different numbers answering the same question. This number here, 13.9 gram of lithium nitride, and this number, 93.7 gram of lithium nitride. Your final answer, and the one you should box, is the one with the smaller number, because the limiting reactant limits the amount of product you get at the end. So, doing what we kind of did with number 1 and 2, you can identify that lithium is our limiting reactant. And because lithium is our limiting reactant, whatever amount of product that's produced from lithium must be our the real mass of the product that's produced. So that is why our final answer is the smaller number. So I'm going to box this here to indicate that that's my final number. Whenever you encounter this kind of question where it asks you to calculate the mass of a product and you do have to do 2 different calculations, just keep in mind that you do have to choose at the end the correct number, or this, because there's only 1 correct answer, and that's the one that's the smaller. Let's go ahead and go through number 6, where the question no longer asks you either for limiting excess reactant or the mass of the product. It's asking you now actually the mass of the excess reactant that's remained. So we know that the excess reactant, some of it get used up in the reaction, but because it's excess, you should always have something left over at the end, and that's the amount of leftover. That's what we're trying to find. Now, same thing with before, where we have 2 pieces of information. Here I have zinc react with nitric acid to produce hydrogen gas and zinc nitrate. I have piece of information number 1, 10 grams of zinc, and piece of information number 2, 7.84 grams of nitric acid. Because I have 2 pieces of information, you know you should have 2 different calculations. Now, for this question, your calculation should answer this question. How much of one reactant needs of the other reactant? So let's start with our reactant number 1, which is zinc. And what I want to do is I want to go from gram of reactant 1, number 1, go to mole of reactant number 1, go to mole of reactant number 2, and then go back to gram of reactant number 2. So that's my game plan here. That's what I'm trying to do. So let's do our 2 calculations. First, let's do 10 gram of zinc, which is our reactant number 1. I want to convert that to mole, and I want zinc at the bottom and mole on top because I want mole to stay and gram to cancel. Knowing our molar mass for zinc is 65.38, 1 at the top. Now I can move on to converting mole of zinc to mole of nitric acid, which is our other reactant. So knowing the chemical equation, a mole of zinc at the bottom and then mole of nitric acid at the top. And I get 2 to 1 from our balanced chemical equation. And then going now from mole of nitric acid back to gram, using the molar mass, and the molar mass is 63.01 gram. I want to punch this into the calculator to give me 19.3 gram of nitric acid. So what this means is that you need 19.3 gram of nitric acid to react with 10 gram of zinc. Now let's go through our second calculation where I want to find out 7.84 gram of nitric acid. How much zinc is needed in order to react with 7.84 gram of nitric acid? And like always, I want to go from gram to mole using the molar mass. So the molar mass of nitric acid is 63.01. 1 mole of nitric acid. Now I want to go from mole of nitric acid to mole of zinc. And I know that 2 mole of nitric acid has to be at the bottom because I want it to cancel out. And 1 mole of zinc at the top because I want to keep it. Then now I want to convert that back to zinc, and I know 1 mole of zinc is 65.38 gram of zinc. Okay. My final answer after I put that into the calculator is 4.07 gram of zinc. I want to look at these two numbers I just found and determine which one I have more than what I need. So I need 19.3 gram of nitric acid, but I only have 7.84 gram of nitric acid. This tells me that nitric acid is our limiting reactant because in order to react with the entire 10 gram of zinc, I need basically almost 20 gram, but I only have 7.84 gram. That means nitric acid is our limiting reactant. This means that zinc must be our excess reactant, but let's check that real quick. I have here, I need 4.07 gram of zinc, but I actually have a lot more than that. I have 10 gram of zinc, but I only need 4.07 gram of zinc to react with all the nitric acid that I have. So zinc is our excess reactant. Now this takes us to the last step of this calculation. I'm going to subtract 10 gram of zinc at the beginning is what we have, minus 4.07 gram of what's actually is what we needed, and the answer to that is the excess reactant that remains. So the answer is 5.93 gram of zinc left over. So the 4.07 gram here is the gram of zinc that get used up in the reaction, and this is actually what we have. We have 10 gram, we used 4.07 grams, so what we have is 5.93 gram left over. Alright, and the answer to this last question is how many grams of limiting reactant remains. And by definition, you know that limiting reactant get completely used up in a reaction. So let me just pull you back here to this problem I just did previously. And we know that zinc is our excess reactant because we have a lot more than what we need. We need only about 4 gram, but we have 10 gram. And for nitric acid, which is our limiting reactant, we need 19 gram, but we only have 7.84. This means that this whole thing, 7.84 gram, will be completely gone, will be completely used up because we need this much, but we only have that. So all of it will be gone. So that being said, the answer to this question is a simple 0. So grams of limiting reactant remains is 0 gram. That's it, you guys.